Hello, now it's Wednesday, the 29th, and I'm wearing the same thing because I'm doing it on the same day. So now we're going to take this one you talked about on Monday and Tuesday, solving quadratic equations where you just had the x squared term and a constant. Now we're going to take it one step further, so to speak. No constant this time, but now you have the x squared term and the linear term. So today's LEQ and today's learning goal, notice they're very similar. How can you solve a quadratic equation by factoring the greatest common factor? And I can solve a quadratic equation by factoring the greatest common factor. You should be able to do that by the time you're done with this lesson, either today or tomorrow. So some of these slides that are in your notes that you've got are not going to be notes that you need to write on. And some of them you will need to add some stuff to. But let's take a look. So using the distributive property here, it gets real easy. This is just straight up distributive property, and we saw this a little while ago. Let me move this down here a little bit so I can get to my tools. So using this distributive property, if I'm going to multiply this out, I'm going to do 3x times x, 3x times x times x is x squared. So I get 3x, and then control period gives you the exponent. And then you got to do it again to get off the exponent. And then 3x times 2 is 6x. There you go. That's all that is. And so I can do the same thing with others of these. And so this one is going to be 5x times 12. 5 times 12 is 60. So this is 60x this time, minus 5x times x is 5x squared. So there we go for that one. So now I'm going to multiply. Now I'm multiplying by a half. So multiplying by a half, negative 1/2 times 24 is negative 12x squared. And then half of 18. So this is going to be minus because I've got this negative times this positive. So it's going to be minus 9x. And then the last one, and all of these should be real easy for you. You get 12, negative 3x times negative 4 is a positive 12x. And a negative times a negative is a positive. 3 times 5 is 15x squared. There you go. So that's all of those. Now, none of those should have been a problem. Those are all your answers for this one. You shouldn't have really had a problem with any of those, straight up distributive property. So what you do want to notice, though, down here is that in all of my answers, I've only got two terms. There's nothing else I can combine. Nothing else I can combine because x and x squared are not like terms. So if I've got two terms inside here, inside my parentheses that I can't simplify, then I better have two terms without parentheses that I can't simplify. So if you end up with two x terms here, then you probably forgot that 5x times x is 5x squared and you just left it as 5x. So please, please, please double check what's going on there. So as I move down to the next one, what we're going to end up doing, now we are going to talk about reversing that distributive property. So we're on the next page. We're going to talk about factoring. I want to look at factoring these quadratic expressions. So you're going to go backwards from what you did in the previous slide. So instead of multiplying out, we're going to divide out. That's what backwards from multiplication is. So you're going to look for what the terms have in common and factor that out so that you have something times something to give you what you started with. So this is my example, 9x squared plus 18x. You should be able to see right off the bat that both of them have a 9 in common, but both of them also have the x. A lot of people can pick up on the number part, but forget about the variable part. So don't forget 9x is your common term. So we call 9x the greatest common factor. Now, yes, they both have 3x as a factor, but it's not the greatest. You want to find the greatest. So that's what's going to end up out here. So now what do we put inside the parentheses? Well, I'm going to divide both of these by 9x. So 9x squared divided by 9x, the 9's cancel. This x cancels with one of those, leaves me with x. 18x divided by 9x is 2. So x plus 2 is what gets put inside my parentheses. So 9x times x plus 2 is equivalent to 9x squared plus 18x. So if you distribute the first, you will get the second. So this is what that second page of yours, third page, I guess, of your notes looks like. So now I am going to ask you to do these. So do these on your paper. You can use a text box and fill those in on your Google Slides, and I'm going to pause here so that you have time to look at those, and then we will come back and get your solutions for that. Okay, so you should have enough time by now to figure out what that greatest common factor is. Here, my greatest common factor, 12x, 24x squared would be 12x. Here should be 5x. Here, now this time it doesn't go into evenly with one of them. So this goes in, 3 goes in and 3 goes in. So negative, because they're both negative, I'd pull that negative out. Negative 3x. And here, even though it's a little bit harder to tell, 14 goes into both of those. So this... There it is. Should be your answers for this work. So 12x, 5x, negative 3x, and 14x. So when I divide this by 12x, I get 1 minus 2x. I divide this by 5x, I get 5x plus 6. I divide this by negative 3x, and I get 2 plus 9x. And I divide this by 14, and I get 8x plus 5. If I were to multiply these back out, this is how you check. If I was to multiply these back out, I better get back to where I started. So double check that. Do that little rainbow thing as you distribute that, and make sure that you get what you started with, because those should be equivalent expressions. So that's how you know. Sometimes you find a common factor when it's not the greatest common factor. Like here, I could use 3, I could use 4, but that wouldn't give me the greatest common factor. You want to make sure that there's nothing else inside your parentheses that those two terms have in common. So now I'm going to move on down here. So last Monday, we investigated how, not this past Monday, but the week before, we investigated how to find x-intercepts. So that's related to this. We actually used these types. So if I use this as my example here, and here's the example that I'm going to use. If I've got f of x equals 3x times x minus 5, it has intercepts at 0, 0, because that's when this is 0. And 5, 0, because that's when this part is 0. These will make the values equal to 0. So if y is equal to 0, then the function's on the x-axis. So put it together. 3x is one of the factors. So what are you multiplying together? You're multiplying 3x and x minus 5. So 3x equals 0, x has to equal 0. X minus 5 has to equal 0, so x equals 5. Those are what we call the roots. So that would be when this thing is equal to 0. So if I took this and made this instead, you just solve that equation. So to answer this equation, that's when x equals 0 and x equals 5. So we take that forward one more step, and what I want you to do is I'm going to ask you to pause again, and I want you to find the x-intercepts of these 4 equations. So I'm going to pause while you do these. You can use your text box. You can use whatever. You can put it on paper. Doesn't matter to me. You could print these out and do it that way. So I'm going to pause while you are coming up with the solutions to this. Okay, so we're back. And so now we're going to take a look at the answers to this. So each section gets equal to 0. And if you look at what we did here, each one of these has this piece right here. And in order for that, it's going to equal 0. So all of these are going to have one of the coordinates, one of the x-intercepts is going to be 0, 0. So this is the solutions that I have. Let's separate that a little bit. All of them, one of the intercepts is going to be 0, 0. That will always happen if I have this, what we call this a monomial, one term factor out in front, will always happen. So this is always going to happen in this case. All right. Doesn't always happen in the previous ones that we have. It won't always happen in the next ones that we look at. But in this case, this is what happens. So all I did is I took this part right here and I solved it, made it equal to 0 and solved. So I got 1/2 0 and 0, 0. So I get x equals 1/2, x equals 6, x equals negative 2/9, x equals negative 5/8. I took this part and solved, set it equal to 0 and solved. This part, set it equal to 0 and solved. This part, including the 8. this part, set it equal to 0, and solve. So those are the answers that I come up with for those. That shouldn't have been hard. We did this last week, and we did this quite a bit last week. So that is what happens here. Well, you just solved these. Because if this thing times this thing equals 0, then either this first one, the part in red, has to equal 0, or the part in blue has to equal 0. One of those two things has to equal 0. And that's going to happen when x is 0, or when x is 1/2, or when x is 0, or when x is 6, or when x is 0, or when x is -2/9, or when x is 0, see the pattern, or when x is -5/8. Those are the values that's going to happen for all of those. So you just solve these equations. Well, if I take it one step further and I say, now I'm going to multiply all these out, guess what you just did? Yay! You just solved these equations. You did it. That's all you have to do. You make sure that it's equal to 0. Notice this down here. This will only work when the equation's equal to 0. If I have like 12x equals 24x squared, I can't take the square root of both sides. I can't divide by 24x. I've got to get it equal to 0. It's got to equal 0 first. Then factor, set them equal to 0, and solve. Just like you would when you were finding your x-intercepts. It's the exact same thing. So you just did that. So now I am going to ask you to do this. This is what you're going to do now. These answers you're going to submit into a test quiz. This is your check your understanding. So when you're done with this, these answers, you're going to tell me which ones. It's a multiple choice, so you'll be able to know right away whether you got them or not. If it tells you no, I'm not going to tell you which ones you got right or wrong. You need to figure it out. All right, so go back and check your answers again. The easiest way to do it is to put them in for x and see if you get 0. If you don't get 0, it wasn't the right one. And watch your negatives. So that's it. I want you to go do these, substitute this in, and then tomorrow we'll do some more practice with this, and then we'll see what comes up on Friday. So have a good day, everybody. Miss you guys.